Hello, in this video I will do a short review on applications of integration. So the first problem we do is find area of some regions enclosed by graphs of functions. And the second problem is find volumes using the disk and shell method. And the third one is find arc length. The next one is find the surface area, and the last one is find center of mass of a lamina with a uniform density. Okay, so let's consider the first problem. Suppose we have two functions, y equal to x minus 1 cubed and y equal to x minus 1. Okay, y equal to x minus 1. They ask us to find the area of the region enclosed by the graphs of two functions. So the graph of these functions looks like this. This is y, this is x, this is 0, this is 2, this is 1. Okay, so you have one function that is y equal to x minus 1, and another one looks like this. And our region is this one. And we need to find the area of this region. You know, the problem is if they give you a picture like this, so you are good, right? You just need to evaluate integrals. Of course, you have to write a correct integral, right? So let me do that for you, okay? And then we discuss the problem. What happens if they don't give you a picture? So if they give you a picture like this, so means we have two regions in here. The first region is this one, right? I call A1, and the second is A2. So it's obvious that A1 is negative area. It's negative area, okay? And A2 is positive area, because A1 is below x-axis and A2 is above x-axis. So in order to find the total area, we need to find the area of A1, area of A2, and then the total area is equal to absolute of A1 plus absolute of A2. Okay, all right, so let's do that. The first area A1, I write integral from 0 to 1. I can write x minus 1 cubed minus x minus 1 dx. You know, actually I wrote x minus 1 cubed minus x minus 1 because in the picture the graph of x minus 1 cubed is higher than x minus 1 on the interval 0 to 1. So that's why we have x minus 1 subtract x minus 1 cubed subtract, x minus 1, But in general, you can write very randomly, like, x minus 1 minus x minus cubed. That does not matter, because at the end, you need to take absolute value right here and right here. So that's okay, okay? So I need to evaluate this integral. And then what is A2? Let's say A2 is integral from 1 to 2. I still write x minus 1 x cubed minus x minus 1 dx. The reason I do that because I want to have the same function in here and then the same function in here. So I only need to find antiderivative one time. And then I just plug integration limit 0 and 1 and then 1 and 2 into those functions. Okay, so let's find antiderivative of this function. So I write x minus 1 cubed minus x minus 1 dx equal to, for the first one I have x minus 1 to the 4th over 4, and then minus x minus 1 square over 2 plus c. Okay, so suppose this is our fx, antiderivative of the whole function. So what is a1, right? So I have a1 equal to f of 1 minus f of 0. F of 1 minus f of 0 is I just plug 1 and 0 into this function. I have 1 minus 1 to the 4 over 4 minus 1 minus 1 square over 2 minus 0 minus 1 to the 4 over 4 minus 0 minus 1 square over 2. Okay, so this is just 0, and this is equal to 1/4 minus 1/2, and then minus in here. So you see, A1 is equal to, this guy is just negative 1/4, right? Negative 1/4 and then minus. So you have 1/4. Positive, that's okay. You know, A1 is 1/4. And then you can plug, you can use this antiderivative function f of x to evaluate A2. So basically A2 is equal to f of 2 minus f of 1. Don't forget that A2 is integral from 1 to 2. So I just plug 2 and 1 into the function f capital, right? X. So I have 2 minus 1 to the 4th to over 4 minus 2 minus 1 square over 2, and then minus 1 minus 1 to 4 over 4 minus 1 minus 1 square over 2. So this guy is 0. This guy equal to 1/4 minus 1/2, right? Minus 0, which is negative 1/4. So that is A2 equal to negative 1/4. From here, I will get the total area is equal to absolute of A1 plus absolute of A2, which is 1/4 plus 1/4 is 1/2. Okay, so you see, actually, in this formulas, what x1 minus x minus 1 cube minus x minus 1. So this integral, that is some kind of, the symmetric. So actually, the value of this guy with the area A2, they have the same absolute value, okay? So sometimes that is not very strictly correct, but this okay, this okay. All right. Now, what happens if they don't give you the picture? What happens if they don't give you a picture? So they don't give you intersections 0 in here, 1 in here, and 2 in here. So you don't have intersections in here. So in that case, you need to find intersections. Okay. So I'll write a very short comment in here. So sometimes you need to find. We need to find intersection. Okay. So how? I will put x minus 1 cube equal to x minus 1. And then you solve this equation. You get first solution is x minus 1 is obvious. So if x is not 1, so you can divide both sides of this equation by x minus 1. So you get x minus 1 square equal to 1, right? Equal to 1. Then x minus 1 equal to plus minus 1, you see? So from here you get x minus 1 equal to 1, or let's say I'll write x minus 1 equal to 0, negative 1. So from here you get x equal to 2 or x equal to 0. So in that situation you already have 3 intersections, you see? You already have 3 intersections. So basically, when you see some problem like that, you have to be very careful. If they don't give you any interval, so you need to find it. Okay? So we finished with the first problem. Now let's consider the second problem. Find the volume of a solid region generated by rotating some region about x-axis or about the y-axis. Okay? So example 2. You have, let me write out functions, okay, and then I will tell you, I will graph those functions, and then we will consider detailed solution. So we have y equal to x squared plus 5. The second function is y equal to negative x squared plus 2x plus 9. All right? So you see, we have two parabolas, right? And they ask us, you know, to find the region enclosed by these two, by the graphs of these two functions, and then x equal to 0 and x equal to 3. Okay, so we need to graph them, right? And in this situation, given that they give you 0 and 1 and they don't give you a picture, so you need to find intersection points. Okay, don't forget that. So you need to find intersection point. So you put x squared plus 5 equal to negative x squared plus 2x plus 9. Okay, so you solve this, you bring, you know, x squared, you bring everything to the left hand side, right? So you have 2x squared, you have 2x squared minus 2x, and then minus 4 equal to 0. From here, you can simplify 2. So you divide both sides by 2, you get x squared plus x minus x minus 2 equal to 0. So you see, this is quadratic equation, right? And the coefficients is a equal to 1, b equal to negative 1, and c equal to negative 2. And you see that a minus b plus c equal to 0. And we know that if our quadratic equation has this property, x equal to negative 1 is a 0. Then x equal to negative 1 is a 0. Okay? So I can write like x plus 1, I factor, right? So x plus 1 here, I have x minus 2 equal to 0. From here, I have x equal to negative 1 or x equal to 2. So, you know, there are two intersection points, x equal to negative 1 and x equal to 2. All right, now let's go back to the assumption of this problem, right? They ask us to find the region, but they give us x equal to 0 and x equal to 3. So I have to be very careful with this problem because, you know, otherwise we can get wrong, right? All right, now let's see the graph of those functions, right? So the first graph is this. This is the graph of function y equal to negative x squared plus 2x plus 9. It's a very brief graph. The second is, you know, the y equal to x squared plus 5. So this is the one, the other one, okay? And so the region enclosed by these two graphs and x equal to 0, okay? Here is x equal to 0 and here is x equal to 3. So basically we have the following region. This is the first one, and this is the second piece of our region. You know, we don't care about the other one, okay? We don't care about what happened when x less than 0. All right, so now we rotate this region about the x-axis, and we need to find the volume of that solid region. You know, the situation is a little bit more general than this method, right? Let me tell you this, right? What is the formula of the this method? So let's say the this method, right? For the this methods, we had formula volume is equal to, I mean, if you have only one function, let's say that, equal to pi integral from a to b f squared of x dx, right? But in this situation, we have two functions, f and g. Is that correct? So we have two functions in here. Suppose this is your fx and this is your gx. So in the first interval from 0 to 2, f of x is higher than g of x, means f of x is bigger than g of x. But on 2 and 3, you know, f of x is less than or equal to g of x. So basically, in this case, we use the wash method, which is a very minor modification of this method. All right, so like the previous example with area, right? Now we have volume, and we need to split our region into two regions, so we need to do two integrals. The first integral looks like this, okay? So here's the first one. V1, I call this is V1, this is V1, okay? And this is V2. So I have V1 equal to pi integral from 0 to 2, because you know the intersection right here intersection is 2 of f squared of x minus g squared of x dx. And then the second one is V2 equal to, I write here pi integral from 2 to 3 g squared of x minus f squared of x, because in this interval g is bigger than f. You see this in the first interval from 0 to 2, f is bigger than g, but in the second one, this is g of x and this is, you know, f of x. So that's why we have to write g squared minus f squared. But I'll tell you this, right? We need only one antiderivative. So like previous problem, I will find antiderivative of f of x squared minus g of x squared. And then I plug 0, 2, and 2, 3 into this, you know, antiderivative to find V1 and V2. That's it. All right, let me show you how to do V1 and V2, right? And we just plug, you know, f and g into this formula. So I have this integral f of x is x squared. Let me see, what is f of x in this case? F of x is negative x squared plus 2x plus 9, okay? I have negative x squared plus 2x plus 9 square dx minus integral g is x squared plus 5 square dx. So our job is, you know, just open parentheses and then evaluate integral. All right, so let me do the first one. Okay, what is the first one? This is a pretty long integral. So I write negative x squared plus 2x plus 9 times negative x squared plus 2x plus 9 dx. And in the other one, I write x squared plus 5 times x squared plus 5 dx. Okay. So the first one is equal to x to the 4 and then minus 2x cubed plus, or no, minus 9x squared. So, you know, you just distribute this. Okay, so you get 3 first term, and then you should have 9 terms in the first integral. And then the second one, I write here negative 2x squared. That's what you start from this term with this guy, okay? And then plus 4x squared, and then plus 19x. All right, next 9, you have minus 9x squared, and then plus 18x, and then plus 81. So you finish everything with the first integral. Then you move to the second integral. You have x to the 4 plus 5x squared plus 5x squared plus 25 dx. Okay, so let's simplify the first one. I have x to the 4, and then with x 2x cubed. So I think I do something wrong in here already. This term should be x cubed. You see, 2x cubed in here should be 2x cubed. So I should have negative 4x cubed, and then plus, so how about x squared? So x squared have negative 9x squared, 4x squared, and then negative 9x squared. So basically I have negative 14x squared, right? Minus 14x squared, and then how about x? So I have 18x in here, 18x in here. That means 36x, and then plus 81 dx. Alright, so the second integral is, x to the 4 plus 5x squared. I have 10x squared basically in here. Let's say I have 10x squared and plus 25 dx. Very long, but it's fine. Oh, by the way, we can simplify this. You see, in this case, I have x4 and have x4 in here. You see, so x4 will be cancelled out. Perfect. And then 10x squared in here, and then minus, and then 10x squared and and then you have 14x squared in here. So basically you will have, just negative 4x squared. Okay, right here, negative 4x squared, okay? And then you have minus 4x cubed in here, minus 4x squared. How about x? X is 36x, and then, 81 with 25, that is 106, right? Everything dx. Perfect. So now you can use the power rule. The power rule, so power rule is what? X to the n dx equal to, I just write separate in here, equal to x to the n plus 1 over n plus 1, okay, plus c. So this guy give us negative 4 x to the 4 over 4, okay, and this guy gives us minus 4x cubed over 3. This guy gives us 36x squared over 2, and then this guy gives us 106x plus c. So let's simplify this. You will get negative x to the 4 minus 4 over 3x cubed, and then minus 18x squared plus 106x plus c. Given that this is pretty long, but we got the answer, right? So that is antiderivative of our integral f squared minus g squared. And now we just plug, number 0, 2, 3 into this antiderivative to find v1 and v2. So basically v1 is equal to pi f of, the whole here is f, okay? The whole function here is f. F of, let me see, f of 2 minus f of 0. F of 2 minus f of 0 in here, okay? And then you just plug 0 and 2 into this function, right? To find f of 2. So f of 2, you can write that. You can find, kind of negative 2 to 4 minus 3, 2 cubed minus 18, And then here you have 2 squared, and then plus 106 times 2, and then minus f of 0. F of 0 is 0, right? C will be cancelled out, so I write here just 0. So basically, you can do, algebra for yourself, okay? And then you can find v2, that is pi f of 3 minus f of 2. You may get a negative number in here, but it's fine because, the total, you get v equal to absolute of v1 plus v2. And this is the volume of our solid region, okay? So, this is pretty long problem, but, with a similar functions, probably you can solve this faster, okay? So I hope that you get what we need to do in this problem. And so we finish the second problem in here. All right, now let's consider the third problem. Use the shell method to find the volume of a solid region obtained by revolving the region and closed by graphs of function y equal to 8 over x squared, y equal to 0, x equal to 1, and x equal to 4, right? About the x-axis. All right, so let's graph the function first, okay? And we'll see. So this is x, this is y, this is o. Our function looks like this, okay? And here, so we have x equal to 1, and here we have x equal to 4. So basically, the region looks like this. All right, you see. I tell you previously, right? We revolve this about the x-axis, but we still can revolve this about the y-axis, right? If we revolve this region about the x-axis, we use this method. So we know that how to do that in the second problem, right? Now let's consider that we revolve this region about the y-axis, so we'll be able to use the shell method to find the volume. Okay. The difference between this method and the shell method is, if you use this method, so your cut, I say this is the cut, right? Your cut is perpendicular to the axis of rotation. So if you revolve by the x-axis, your cut is perpendicular to the x-axis. You use this method. But the shell methods, for the shell methods, your cut, again, this cut, oh, I'm sorry for this. Your cut, this guy, is parallel to the axis of rotation. So this parallel to the y-axis. So that's why, if we revolve about the y-axis, I write here about the y-axis. So we use, the shell method. Okay, let's do that. So for the shell method, we have formula, right? The volume is equal to 2 pi integral from a to b px and then f of x dx. What is px? Actually, px is the radius, because when you do the shell method, you need to find the radius in here from that point to the axis of rotation, and this is your px. But when you rotate about the y-axis, the radius is always equal to px. The radius might be different when you rotate about another axis, okay? So in this situation, p of x is just x. So your integral looks like this, equal to 2 pi integral from 1 to 4 x. The function is 8 over x squared dx. That's it. So you simplify 1x in here and then with x squared in here, you get 2 pi integral from 1 to 4 8 dx over x. So 8 is a number. You can take this out of the integral, right? And you have this equal to 16 pi from 1 to 4 dx over x. So antiderivative of 1 over x is what? That is, ln of x, absolute, okay? And this evaluated from 1 to 4. So we just plug 1 and 4 into this integral, and into this function, we get the answer. So let's say that is 16 pi, and then ln of 4 minus ln of 1. ln of 1 is 0, so basically the answer is 16 pi times ln of 4. And that is the volume of our solid region. Okay, so this problem is pretty short and very easy. Let's consider the next example. Find the arc length of the graph of the given function over some indicated interval. So in this situation, you have function y equal to x to the 5th over 10 plus 1 over 6x cubed. All right, so we know the formula, the arc length. The arc length is equal to integral from a to b square root of 1 plus f derivative of x squared dx, right? So we need to find the derivative of this function and then just substitute everything into the formula. F prime in this case is equal to 5x to the 4 over 10 plus I write 1/6, you know, 1 over x cubed, I write in the form x to negative 3 derivative. Okay, so we write in the power form. It would be easier for us to differentiate. Then this is equal to x to the 4 over 2 plus, 1/6, and then negative 3 in here, and then x to negative 4, just the power rule. So I have x 4 over 2 minus 1 over 2 x to the 4. Okay, or we can write that is 1/2 x to the 4 minus 1 over x to the 4. So that is the derivative. Now I will not substitute this right away, right, into the integral. I will find square of the derivative. I want to work with the function first. Okay, so from here I get f derivative x squared plus 1, that is, the function inside the square root, equal to 1 over 2 x to the 4 minus 1 x to the 4. Okay, and here everything square plus 1. So here we need to use the following formula: a plus minus b squared equal to a squared plus minus 2ab plus b squared. Okay, so I write this is 1/4, because 1/2 squared is 1/4, right? So I have x to the 8 minus 2 times x to the 4 times 1 over x to the 4, and then plus 1 over x to the 8. Okay, plus 1. And you can see this x to the 4 and x to the 4 cancel out. So basically here you only have 2, right? You have 2 out there. So I have 1/4 x to the 8 minus 2 plus 1 x to the 8 plus 1. All right, now we will add 1, right, into this expression. I'll get, basically, let me do this in here. So you have 1/4 plus 2 times 2, you see? That is 1/2, right? Negative 1/2, because you have negative 2 out there. Negative 2 in here, okay? So you have negative 1/2, and then you plus 1, you get 1/2. So basically, in this formula, instead of negative 2, when you add 1, so you get just plus 2. So I write equal to 1/4 x to the 8 plus 2 plus 1 over x to the 8. Now let's pay a little attention on this, right? In here you have minus 2. In here you have plus 2. So why is this, right? So I can just change from minus in here in the very first formula right here. Okay, so I will get, that is just 1/4 x to the 4th plus 1 x to the 4th, and then square. You see this? So if you can compare this formula with the last guy in here, so you can see, and then we use the formulas in here. All right, so that is what happened under square root. Now I will substitute this into the integral. So my integral looks like, I write arc length in here equal to integral from here, we have from 3 to 8, right? From 3 to 8. All right, I write from 3 to 8 square root of 1/4, and here x to the 4 plus 1 x to the 4, okay, square, and then dx. So we have square and square root, that will be cancelled out, right? And then here 1/4 is 1/2 square. So basically this integral is equal to 3 to 8 1/2 x to the 4 plus 1 over x to the 4 dx. You see, because square and square root, they just cancel out. All right, so for this integral is pretty easy, right? I can write just 1/2, and then 3/8 x to the 4 plus x to -4, right? dx. So I took 1/2 out of the integral, and then, you know, I rewrite 1 over x to the 4th as x to -4 because I want to use the power rule. So this is equal to 1/2, and antiderivative of x to the 4 is x to the 5th over 5 plus x to the -3 over -3, evaluated from 3 to 8. And now your job is just plug a and 3 into this function. So you get 1/2 8/5 over 5 plus a to -3 over -3, and then minus 3 over 5 over 5 plus 3 to -3 over 3. So, you know, you can use calculator to find this number, but it's okay to live like this. So that is the problem, how to find arc length. I would mention that, you know, arc length problem is sometimes difficult because the formula square root of 1 plus square of the derivative. You see, because of this, sometimes you might have, you know, very difficult integral. But, you know, it's okay, right? All right, so we finished with this problem. The next example is find the area of the surface generated by revolving the curve on the indicated interval about the x-axis. And our function is y equal to x cubed over 6 plus 1 over 2x. The interval is 1, 3, okay? So we have the formula for this. The surface area equal to integral from a to b, right? Here we have 2 pi. And since we rotate about the x-axis, that is, you know, x, here's f of x, times 1 plus f of x derivative square dx. Of course, we need to find derivative, right? So the derivative is equal to x cubed over 6 derivative plus I write 1 over 2 x to -1 derivative, so that is 3x squared over 6 minus 1 over 2 x to -2, right? And then I write that is x squared over 2 minus 1 over 2 x squared. So you can see that this function is very similar to the previous one, to the function in the previous problem. And that is 1 over 2 x squared minus 1 over x squared. So let me remind you about this, right? In the previous example, we consider 1 over 2 x to the 4 minus 1 over x to the 4. And then when we use square and you add 1, you will change this from 1 over 2, from negative, right? You change to x plus 1 over x to the 4. So this is, you know, very, very standard example. All right, from here, I can write, so 1 plus f derivative x square equal to, I just jump ahead to write equal to 1 over 2 x squared plus 1 over x squared square. So from here, we have the area equal to 2 pi integral from 1 to 3. The function is x cubed over 6 plus 1 over 2x, okay? And then multiply with 1. Here, I'm sorry, here we should have 1/4, okay? Here we should have 1/4. 1/4 x squared plus 1 over x squared, then dx. Again, you have square root and square that will be cancelled out. So I have 2 pi integral from 1 to 3, 1/2, because 1/4 square root is 1/2 x cubed over 6 plus 1 over 2x times x squared plus 1 over x squared dx. And now we just, distribute this with this guy, and then this guy with this guy. So, and then we might simplify like 2 pi and then 1 over 2. So we cancel 2, right? We have pi in here, integral from 1 to 3. So I have x to the 5th over 6, and then plus x cubed over x squared plus x squared over 2x plus 1 over 2x times 1 over x squared dx. So I have pi integral from 1 to 2 x 5th over 6 plus x, right? Because x cubed over x is just x, over x squared just x, and then here I have just x over 2, and here I have plus 2x cubed dx. All these terms are power functions, so I can just write pi. Okay, let's do right here. So I will erase this. I will write antiderivative right away. So before that, we just change this from 1 to x to -3. Okay. So antiderivative of this term is x to the 6 over 6 and times 1 over 6, right? Plus x squared over 2. Okay, and here I have x squared over 2 times 2. Yeah. And then from here we get 1 over 2, x to -2 over -2. And this integral evaluated from 1 to 3. So now your job is just plug 3 and 1 into this function, right? And then, find the surface area. So I will leave this to you, okay? The last problem is find the center of mass of the lamina of uniform density rho bounded by the graphs of equations, right? Our function is y equal to x to 2/3, y equal to 0, and x equal to 8. All right, let's graph them. Sometimes we don't need to graph, but this function is pretty easy, so let's do that. We have y, x, in here, and then, this is the y equal to x to 2/3, and then here is 8, right? X equal to 8, and here is y equal to 0. So the lamina looks like this. And we need to find the center of mass. In order to find the center of mass, we need to find moment, right? We need to find moment with respect to the x-axis and with respect to the y-axis. So the moment mx is rho integral from a to b f of x plus g of x over 2, okay? And here f of x minus g of x dx. Of course, in this situation, f of x is the current function x to 2/3, but g of x is 0, right? G of x is y equal to 0. So our integral is pretty easy. And then my, let me just write out all formulas, and then we will go ahead to solve this. Is rho integral from a to b, then x times f of x minus g of x dx, okay? And once we found moments mx and my, we need to find m. That is rho integral from a to b f of x minus g of x dx. And then we can find center of mass. That is just, mx over m, my over m. And we are done, right? Now, this should be my, okay? This should be my, and then here's mx. So we interchange a little bit. All right, so let's go ahead to solve integrals. Our integrals are from 0 to 8, right? So let's find mx. So I find mx equal to rho integral from 0 to 8 f of x is x to 2/3 plus 0 over 2 times x to 2/3 minus 0, okay, dx. So this is equal to rho integral from 0 to 8, 1/2, so I bring 1/2 out, so I have rho of 2, I have x to 2/3 times x to 2/3 dx, so that is rho over 2 integral from 0 to 8, and then x to 4/3 dx, right? Antiderivative of x to 4/3 is x to 4/3 plus 1 over 4/3 plus 1 evaluated from 0 to 8. So, just plug 8, because at 0 the function is 0, so we have rho over 2, and here we have 7 over 3 x to 7, or I can write not just x, I write right away 8 to 7 over 3. Okay, what is 8 to 7 over 3? Let's say 8 7 over 3 means 8 power 7 and then cube root, or we can write 8 cube root and then power 7, right? A cube root is 2, so basically that is 2 to 7. And here I have rho over 2 and then times 3 over 7. I have 2 to 7. So what is 2 to 7? You can use calculator, okay? So you can buy some, let me see, that is 2 times 2 times 2 times 2 times 2 times 2, 1, 2, 3, and times 2. That is 4, 4, and 4, and 2, so means 8 in here and then 16 in here. 8 with 16 is 128. So I have 128 divided by 7, and then I have 2. So we simplify 2. Oh my goodness, it would be easier. So I have 64 times 3 over 7. That is 192 rho over 7. So that is the moment mx. Okay, I write here mx. And then we can find my, and y is the moment with respect to the y-axis. So my is equal to rho integral from 0 to 8 x f of x, x to 2/3 minus 0, because the y is 0, right? So I have, rho integral from 0 to 8 x 2/3 plus 1 dx. Because x, when you multiply them, we get that 0 to 8 x to 5 over 3 dx. And now we just find antiderivative of this guy and then plug 0 and 8 into this function. So I have x over 5 over 3 plus 1 over 5 over 3 plus 1 in here, evaluate from 0 to 8. But at 0 the function is 0, so we need to find function value at 8. So I have rho in here divided by 8 over 3, okay? So 8 to 8 over 3. Oh no, yeah, 8 to 8 over 3. So like the previous computation, we have 8 over 3 is just cube root of 8, then over 8, right? So cube root of 8 is what? Is 2 over 8. So basically this is rho times 3 over 8 times 2 over 8. But 8 is 2/3, right? So basically that is, I can buy 2 to the 5th. 2 to the 5th is, 32 times 3, that is 96. So we have 96 rho. And this is my. Alright, so we still need to find m, right? The mass of the lamina is equal to rho integral from 0 to 8 x to 2/3 dx. Again, you need to use the power rule. So that is rho x to 2/3 plus 1 over 2/3 plus 1 evaluated from 0 to 8. So basically that is equal to rho 8 to 5 over 3 over 5 over 3. That is equal to rho 3 over 5. And what is 8 to 5 over 3? That is cube root of 8 power 5. So that is 2 power 5. So I have, that is 32, right? 32 times 3 times 3. So I can write, okay, I write 32 in here. And then 32 times 3 is 96 over 5 rho. Alright, so that is the mass of the lamina. From here, I can write the center of mass. That is, my over m and mx over m. So you just plug numbers into this, you get, what is my? My is 96 rho over 96 rho over 5, right? And mx is 192 rho over 7. 192 rho over 7. And then, divide by, oh, not beautiful, but that's fine. 96 over 5 rho, right? So basically we can simplify them. We get 5 in here, and then in here we get rho, and then 2 times, basically that is 10 over 7. So this is the center of mass. In this problem, basically we use power rule for integral. So I think we did a very short review on main problems in applications of integrals, right? So I hope that this video is useful and help you to study better. Thank you for watching.